Today we are going to just look at some hands-on AI risk assessment with some open tools, and more excitingly, we are going to see how we can actually use something that we have built all by ourselves to do the AI risk assessment from a both framework standpoint and from a very specific metric standpoint as well. So I'm going to be switching over between the PowerPoint and the browser window. So if you have any questions, do please raise your hand or just type it inside the Q&A or the chat session, and we will go from there. So I want to first set some context on the discussion that we have had yesterday. In case you missed it, then you can actually follow through as well. In the session yesterday, we introduced a tool that DeepDive Labs has been building, and the tool is called adversarial.tech, and you can navigate to the AI risk management session. In the risk management framework page, yesterday we saw a few of these frameworks, specifically the NIST AI risk management framework, the ISO frameworks, and the responsible AI architects guide. And we had also looked at the supervisory guidance on model risk management. Now, in case you hadn't had a chance to attend the session yesterday, I want to just give a very quick overview of what these frameworks are before we get started on the actual risk assessment part. What you're seeing here is what is called as a supervisory guidance on model risk management. The idea behind this is there is an organization. It might be a specific organization within the context of a commercial one, or it can be an organization in any other place as well. And they usually publish some kind of guidance on risk management. And what this particular SAS has done is it has absorbed that entire framework. Usually, if you click on this particular link, you will be able to see what that particular framework looks like. In this particular case, it is a PDF of 21 pages. And that particular PDF has been distilled into a set of different pivots for each controls and descriptions giving different kind of requirements. So for example, it tells you what that particular framework is asking from a model implementation standpoint, from a model use standpoint, validation standpoint, and others. You can also click on the informational icon here, and you will be able to see what that particular framework is giving as part of the recommended actions and some documentations to be done as well. So this is what we have covered yesterday in terms of the practical implementation, or in terms of how the SAS that we are developing is actually projecting all of these risk management frameworks here. Now, with that said, let's now move on to some other basic concepts that were covered in the session yesterday, so that we can use that as a background for our session today. This particular slide is talking about a set of key AI-specific risks. Specifically, it's talking about hallucination, bias, drift, misuse, and over-reliance. Each one of this was covered in depth yesterday during our session, where we talked about what these kind of risks are and how they actually manifest in different usage types for these AI usages. Here, when we say AI, although the latest trend is to just understand it as LLM usage, it can also mean any other kind of system where you have some machine learning algorithm at the background as well. These ones are a bit more specific to the LLM-based usages, though the notion of drift can also be applicable for different models as well. So with this as the background, today we are going to see how we can measure these risks and how we can do it in a more prescriptive manner using some existing tool sets. So we are going to be walking through some of the tool sets here, and I will walk through how they are actually used. And there are some background information in terms of technicalities which are also present in this deck, but they will not be covered in the interest of time. We can always take questions or during follow-ups for that. So let's start with the open source AI risk tools. Now, in the session yesterday, we talked about all the different risk frameworks And these risk frameworks have some common themes. So some of those themes are fairness, transparency, robustness, and others. And what we have here is a category of different AI risk tools for each of these themes. So the first thing here that we have is the notion of fairness. And in this particular idea of fairness, we are going to talk about two tools. One is AI Fairness 360, which can be used for bias detection and mitigation. And the second one is Fairlearn, which is for post-training fairness, and it is accompanied by dashboards as well. Then the second category we are going to talk about is understanding the notion of robustness. Here we are going to talk about two additional tool sets. One is called Foolbox, which is used for adversarial attacks, and the other one is called Robustness Gym, where you can stress test with the real world shifts for your data and others. Last but not the least, there is this notion of transparency. And here we are going to just introduce two very broad tool sets, so to speak. One is the Responsible AI dashboard from Microsoft, and the other is an AI verified toolkit from the Singapore framework and initiatives. So the entire walkthrough is going to be trying to understand what these tools are, but not necessarily from a deeply technical standpoint, because each of these tools is deeply technical, and they actually deserve maybe a day or two of a boot camp by themselves. But the idea is for us to understand under what circumstances can these be used and how they are going to be used as well. So let's get started with the fairness assessment tools. So AIF 360 has been started off by IBM, and the focus was in detecting bias in the data sets and the models. So what it actually does is it provides a bunch of what is called a bias metric. That is to say, when you think about a use case and you think about bias, there are different ways in which you can quantify that bias. And what this particular toolset does is it provides a lot of these bias metrics in this particular case. It also includes some mitigation algorithms once some biases have been detected as well. So this is the first toolset. The second one is Fairlearn. Although it says Microsoft, it started off as a research project from Microsoft, and it is now maintained in GitHub publicly as well. And there are different stakeholders that also go ahead and promote it and contribute to it. The focus for Fairlearn is to do what is called post-training fairness evaluation and mitigation. And in this particular case, it integrates with scikit-learn pipelines that we usually have here as well. So, and the last one is it offers dashboards for subgroup performance comparisons. So let's actually now go through some of these and see what exactly they mean. So the structure here is going to be the use case for each of these tool sets so that we understand under what circumstances they can be used. So let us talk about the first one. This is for AI Fairness 360, and the use case here is a fair loan rule. So here is the sample scenario. Please give me a minute. I'm getting some feedback that my voice is not very clear. Let me just try to redo my audio. 1 second, please. All right, folks. Can people hear me better now? If you could just type inside the chat window, I would appreciate it. Okay. Thank you very much. All right. Give me just a minute so that I can go ahead and start sharing. Apologies everyone for that technical hiccup. So hopefully you can all hear me better now. I will just very quickly walk through the earlier session that I had, the earlier slides I had talked about, just so we can get on the same page. So on the right hand side, I have a list of the key AI specific risks, and I was sharing this so that we could just set a context on what was covered in the session yesterday. So in this particular case, we talked about hallucination, bias, drift, misuse, and over-reliance. And these were the specific risks that were talked about in the session yesterday. So the purpose of the session today is to understand how to measure these specific risks. In this particular context, we started talking about different open source AI risk tools. And to kick it off, we started looking at the different categories. So here on the left-hand side, you see three categories: fairness, robustness, and transparency. And these were the common themes in some of the AI risk management frameworks that were introduced yesterday. So these are the categories of the AI risk tools. And on the right hand side, you have the examples of the open source tools that are available for measuring them. So let us get started with fairness, which is for AIF 360, which is for bias and mitigation. So AIF 360 owes its origin to IBM, and the idea here is to detect bias in data sets and models. What it excels at is it provides dozens of bias metrics, that is to say, whether they are disparate impact or equal opportunity difference and others. And they are defined differently, which can be used based on your use case. It also has what is called a set of mitigation algorithms so that you can reweight or do what is called adversarial debiasing in your existing data set so that you can go ahead and understand what the particular bias is and also correct it. Now, I will just move on to the next one to give an example of what this particular use case for AI fairness would be. So let us assume that a bank is using an ML model for personal loan approvals. So the concern here is usually when you have these kind of prior data, there might be a data bias. There might be unfair treatment for certain people across gender or across race as well. And when you're thinking about a regulated industry like a bank, the regulators require demonstrable fairness and compliance. So what AI 360 does in this particular case is it detects the bias using metrics like the disparate impact or equal opportunity bias. And it does so in three kind of steps. One is it tries to understand from a pre-processing standpoint whether there is a bias, and then it will resample or reweight all of the data sets that is available in order to normalize it. There are also other processes that are involved for what is called in-processing and post-processing stages, where these debiasing during training and calibration is done there as well. And finally, we do an evaluation to compare the accuracy and fairness before versus the after the intervention. So this is a use case where you can think of the AI Fairness 360 for usage. The benefits are obvious in this particular case. It ensures regulatory compliance. You also have customer trust and it reduces legal risks as well. Now, in the session yesterday, if you recall, we talked about the HSBC system, where it was also trying to understand the usage of a certain model for banking scenarios as well. So you can think of the banking scenarios that HSBC might have used a model for, and in order to approve or to understand the fairness of that particular model, you can always use the AI Fairness 360. So within this context, I want to also set the specific stage here. So what is the relationship between what you see on the left-hand side, which is the supervisory guidance on model risk management, and the usage of this particular tool, AI Fairness? What that simply implies is when you think about the aspect of measuring models, so in this particular case, model validation, there is a requirement where banks must establish independent model validation processes with appropriate incentives and competence. And they should also evaluate conceptual soundness, including developmental evidence as well. So one way to measure all of these is to do it using these open source tools. So this is one particular way of tying what you see on the left-hand side, the AI risk management framework, with the actual tool on the right-hand side. In some cases, there might actually be a very specific recommendation saying you can use this particular toolset as an example, but that is just an example. You can choose whatever toolset you want to in case you are responsible for ensuring fairness, but this is one way to get started with what toolset you would like to do. I'm now going to very briefly look at the chat to see. Okay. And now let's now go ahead with the next scenario. After the use case for Fairlearn approvals, this is the the model card or the deep dive into the AI fairness toolset, so to speak. In the interest of time, I will not be covering this on a step-by-step or a point-by-point mode, but just to very clearly talk about what this is. It is an open source toolkit. It's available both in Python and R, so that you know where the implementation comes from. And it's currently to the Linux from umbrella somewhere around the 2020. Now, in order to do this particular kind of a testing, you have to understand what the core components and the practical use are. So for each of these toolsets, there are going to be a lot of fairness metrics. So in this particular case, it has more than 70 fairness metrics, and then there is a set of bias mitigation algorithms. So the application of these metrics and algorithms is really dependent upon the data set that you have and the usage that you have. So the as is always simple and very common in any of these kind of data science or AI related projects, the first step is to try and understand the use case that you have and the data set in order to then meaningfully apply each of these fairness metrics and the mitigation algorithms. The usage there will actually give you an idea of under what circumstances you should be trying to use AI 360 here. Now let's move on to the second one, which is the Fairlearn. So here is the use case for Fairlearn. So let us assume that a company is going to be using machine learning models to screen job applications. So their concerns would be that the model might unfairly disadvantage candidates based on gender or ethnicity. In fact, in one of our earlier courses, we had even talked about how this particular situation came to bear in reality when Amazon had tried to roll out some of their AI-based resume screening algorithms. In that particular case, unfortunately, they did find that women were unfairly disadvantaged during the resume screening, even if every of the other qualifications are exactly the same here. So now, in this particular case, the usage of Fairlearn here is it will detect the disparity in the model outcome across the sensitive groups. So that is to say, you have to be very categorical about what the sensitive groups are and give that as an input to this particular tool set. and then it will apply the fairness constraints during the training itself. So it also is in a position to give you the accuracy trade-off visualizations so that it's very easily presented to a stakeholder. And in that particular case, you can understand what is the predictive power with respect to ethical obligations. Now, AI-based resume filtering and the job, interviewing is a big area by itself. But you can see where these kind of tools can help start making things a bit more fair based on how the usage is. There are a lot of benefits here which are pretty straightforward given this particular use case. So again, we will just go ahead in the interest of time here. Now, the Fairlearn toolkit, it also has a set of cards, so to speak. There is a definition and mission, the social technical perspective, and the community governance as well. But what is also important is to try and understand how it is going to be different from the earlier fairness tools. So in this particular case, you have different set of built-in fairness metrics. For example, demographic parity, equalized odds, the so-called worst-case accuracy, and others. Now, each of these specific algorithms and metrics, they can be dealt in with a deep dive. But the idea is to try and understand what these metrics are and when to apply them again based on your particular use case. There is, of course, the so-called reduction algorithms and some post-processing algorithms where you can go ahead and use it to apply it on your data set to ensure that whatever model you're going to apply is still going to be fair as well. Okay, so let's now move on to the robustness evaluation tools here. Now, it's important to distinguish what is the difference between fairness versus robustness. So we will do so using the use cases as before. In this particular case, we are going to discuss two toolsets. One is the Foolbox and the other is called the robustness gem. The focus of Foolbox is in what is called adversarial robustness. And what it does is it generates perturbations to test the model resilience. Now, what does this actually mean? Let's just go through the use case and we will understand that. Putting things back together from the session yesterday, you might recall that in the session yesterday, we talked about a use case where Changi Hospital was trying to understand the summary of the diagnosis, the performance of summarization of diagnosis based on some LLMs, and they are trying to understand whether it is meaningful or not. So now let us try to take that one step forward and see in this particular use case what is robustness testing. The context is, imagine a hospital team that is building a chest X-ray classifier, and the idea is you get an input image and then the AI after processing will tell you whether it is normal pneumonia or a COVID-19 related illness. So what is the concern here? When we say the small perturbations can cause dangerous misdiagnosis, it means that when you're having this kind of an image and you have some certain perturbations in the image itself, then is there a possibility of a dangerous misdiagnosis? So for example, you could just have a normal chest X-ray, but then the AI could misdiagnose it as pneumonia. So what Foolbox does is, from a technical standpoint, it takes the model and then it wraps it under some kind of a class structure that this has, and then it applies certain gradient descent algorithms to go ahead and test the sensitivity of that particular model. So anytime there is an input image, it will apply these kind of attacks and then give the updated image with the perturbation into the model, and then it will see whether the diagnosis is still the same or not. And then it will also try to measure what are the minimal perturbations under which the model is still giving you the same answer, and the threshold beyond which it can go ahead and start, misdiagnosing. And once you do that, you can try to retrain it, the original model itself, with what is called adversarial training, and then retest it. Adversarial training simply implies that you take the image and then you deliberately introduce some noise into it, or some perturbations, and then with that kind of a noise, you go ahead and test the actual model that is supposed to give you the diagnosis. So as a sample outcome, you can find high vulnerability to these attacks, and then hopefully the adversarial training can improve robust accuracy. I do want to stress this is an example use case. This is not a real one. So this is to help understand what is the utility of this kind of toolset and what does it mean when we say robustness. So robustness in this particular case is how robust is the model to detect whether an X-ray image is, indicating pneumonia, normal, or COVID, even under a perturbation or a slightly adversarial attack, so to speak. Excuse me. So again, we have a set of toolboxes here to understand what this particular toolbox does. We will all share this particular slide so you can have this background as well. The core components and the typical workflow again, as before, every time we want to go ahead and apply one particular tool set, we need to first understand what our use case is so that we can go ahead and see whether this particular attack suite or others, whether they are actually valid for this particular use case that we have. So this is the Foolbox robustness example. Let's now move on to the robustness gym. So again, we will motivate this through a use case again. We know this idea of sentiment classifier. So the idea behind sentiment classification is if you are an online store and you have some customer reviews, you want to be in a position to see whether the sentiment is positive or negative. That is very broadly speaking. But then beyond just saying whether it is positive or negative, you want to be in a position to know some nuance as well. So the context here is, let's assume that a startup is deploying some sentiment analysis model for some customer review. And the goal is we want to check robustness to noisy text and fairness across short and long reviews, right? So what does this particular robustness tool do? The first thing it does is it does what is called subpopulation slice. So it takes this particular data set and it is in a position to slice it based on certain parameters. In this particular case, it can do either whether it is a short review or a long review, and then slice the reviews based on some kind of a parameterization of the length. Then it can do a transformation of each and every slice where it can add an artificial typo based on some parameter again. And then instead of giving the original text as it is to the model, you can now evaluate the model performance along the baseline, along the long review, and along the noisy review slices as well. So the idea here is again, how robust is the model at detecting the input sentiment based on whether there is a typo or whether the particular length of the review is short or long. So as an example here, again, some sample findings, you could have a base data set accuracy of 91%, but then if you're going to be reviewing a long review slice, it might actually go down. And if you have a slice where you have artificial typos introduced, it could go down as well. So then you can understand to what extent is the model that you are deploying robust in some sense. And the outcome would be to identify the weakness in the long reviews or the noisy reviews, and then augment the training data and then retest it with the robustness gem as well. So these are the robustness mechanisms by which you can try to understand whether a model is robust for your given use case. So again, we have a set of these specific background information on this particular tool set. And as before, if we go on to the next one, the key components and the typical workflow, we will still need to understand to what extent our specific goal is and our specific use cases, whether you can take this particular tool set and take it into a slice and evaluate it based on subpopulation introduce what is called a transformation or an adversarial attack. Finally, there is of course a bunch of toolings in terms of the scoring and the metrics and others as well. So this is the second category of tool sets, which is around robustness. Now let's move on to the third category here, and this is around transparency and explainability tool sets. But this particular set of tool sets that you see here is a bit more broader than just transparency and explainability. There is one which is called the Responsible AI Dashboard, and this is released by Microsoft. And there is the other, which is the AI Verified Toolkit, which is released by the Singapore IMDA as part of their initiatives. So both of these are sort of holistic, but they do it for a lot of these kind of different errors or the AI risks that we have. So in the Responsible AI Dashboard, for example, you can combine fairness, error analysis, causal inference, and everything else, and you have a very nice GUI to actually show what it is. However, the disadvantage between both of them is there is a huge upfront setup cost for both, and in terms of actual stability, you need to be very clear about certain versions, and it's not what you would call something that is plug and play. That is to say, if you have an existing API, it's a bit difficult to actually just plug in the API into each of these toolsets and start getting these kind of fairness, error analysis, and other metrics as well. However, as before, they sort of work with a lot of other individual toolsets, so you have that going for you when you think about the Responsible AI Dashboard. Now, from the second part, the AI Verified Toolkit, this is released by the Singapore IMDA, and there are two specific types of toolkits here. One is just the AI Verified Toolkit, which can be used for any of the ML algorithms that you apply. And then they have another one, which is called AI Moonshot or Project Moonshot, as I recall, which is used for testing LLMs as well. However, again, because of the nature of the level of maturity of these projects, there is a lot of specific backward compatibilities in terms of installing them, and they are not necessarily immediately plug and play. However, the advantage with the AI Verified Toolkit is they also have some sort of a testing framework, and I will very briefly switch over and show you what that particular testing framework looks like. So we are here on the Red Experience toolset, and we are looking at the AI risk management framework again. And if you look at the model AI governance framework for generative AI, this is from the Infocom media. And if you look at the details, you can click on the framework and you can see what their release is. So this is their model AI governance framework for generative AI. What this particular software has done is it has again taken all of them and mapped them differently depending on their dimensions. So on the top here, you see the first dimension is govern, the second is map, the third is manage, and the fourth is measure. Because of the way they have been designed, this very closely limits the list AI RMF dimensions that are already there. And each of these requirements that you see here have been derived from the actual model framework that you have, that the AI Verified Foundation has been publishing here. So the advantage with the AI Verified Toolkit is if you were to go ahead and use them and get some results, you could plug in those results once you start creating an assessment based off their framework. So as an example, if I were to create an assessment, which is a test assessment for a test company and with some test details, you can see that this particular assessment will have options to go ahead and provide implementation notes, the expected risk, and some mitigation notes for each and every one of their controls. So this allows you to go ahead and use the AI Verified Toolkit, and then for each and every of these requirements, whatever report it gives you can be put in as an implementation node specifically for going ahead and creating an assessment, but very specifically based on their governance framework. So this is the final set of top level tool sets, so to speak. Now we are going to switch gears just a bit and we are going to see how we can actually use or take each of these risk metrics that we have just seen so far and implement them using just plain LLMs using a concept called LLM as a judge. I'm going to switch over these comparative use cases in the interest of time. You can always look them up once the slides are shared with you. So we are now going to switch and look at the concept of LLM as a judge, and then we are going to tie it back together to the notion of AI risk management. So what is LLM as a judge? So the idea behind LLM as a judge is you have these large language models like ChatGPT, Claude, and others, and you want to use one of them to evaluate the outputs from another LLM or even the same one. So the core idea is that the large language model is going to act as a judge against some explicit evaluation criteria, and it is supposed to replace or supplement the human evaluation. This particular notion of replacing or supplementing is depending on how you design the system. Now it reduces a lot of manual effort, and the idea is even without the ground truth labels, you have some mechanism of getting some sort of an evaluation as well. So here is an example of what this means. For example, if you have a chatbot and the chatbot is giving a response to a user input, the output of the chatbot can be judged by the LLM by giving its output and asking it a simple question: is this response polite? Or does this answer contradict the provided source? So in this way, the LLM as a judge is in a position to actively understand what is actually being told, and based on what is actually being told, give a judgment whether the answer is meaningful or not based on the prompt that you have given. Now, as before, let us just see a couple of use cases so that we can motivate this. So this first one is a customer support quality monitoring. So let us assume that you have an AI chatbot that handles billing, subscription, and other queries, and the company needs these responses to be respectful, accurate, and complete. There have been a few cases where there have been problems because of that. So you can very easily imagine LLMs as a judge being very useful here. So the way the LLM as a judge would be applied here is you would provide it some criteria that says, I want the tone of the response to be such and such. I want it to be accurate based on a given knowledge base, and I want it to be complete. And then the judge can evaluate each of the chatbot response before the conversation is actually given back or even post conversation. This really is a design decision, but let us assume it is done post conversation. So what it can do is it can flag all the problematic answers back for a human review. So what this means is you are in a position to have a scalable Q&A, so you can review 100% of the chats and you can do faster feedback loops as well. So this is one particular use case. Now let's look at another use case where you have an academic grading assessment. So let us assume that you have a large class with hundreds of short answer submissions, and obviously manual grading is going to be very inconsistent and time consuming. So as a consequence of that, we want the LLM as a judge to step in and start helping us out with this academic grading assessment. So again, you would give a criteria saying, I want the answer to be evaluated based on completeness, accuracy versus the reference answer, and the clarity. And then the judge can evaluate the answer with binary labels and give a rationale as well. So what this means is a teaching assistant can review only ambiguous or flagged cases if they need to. And the benefits of this are obvious when you're thinking about a large cohort. So give me just a minute. I think we have a point in the question. Okay. I think that was just somebody saying we have to leave, but thank you for attending as well. So let's now move on and let's see why it can work. So what is the difference between critiquing versus creating? The idea is that humans and LLMs, they find it easier to spot the errors than to produce all these flawless outputs. So there is also this particular notion of role separation. There is one model that can be used to handle the user intent, memory, and everything else, but then the judge model will only inspect the final text and apply specific rules. So effectively, the cognitive load on the judge model is actually quite lesser here. And last but not the least, it is very much resistant to manipulation. So what that means is the chatbot might be tricked by some adversarial prompts and there is a possibility of it jailbreaking, but the response of the chatbot is only going to be evaluated by the judge. So the evaluated reviews only the final output, and therefore you can enable a bit more of objective judgments here. So this is one of the reasons why it does work. I'm now going to skip where to use it and just move on to the two modes of judging, after which we will actually show some code so that we can motivate this further. So just as an example, the first one to do here is pairwise comparison. You can just take two responses, whether the two responses come from two different models of the same LLMs, that's immaterial. But you can ask the judge which of these two responses is better. So it is good because it's intuitive and it's useful for prompt tuning, but then it is only relative results. If you have two models that are equally bad, then you're not really going to be getting a whole lot of advantage from this. Then the second part is direct scoring by criteria. So you can very clearly say something like binary or narrowly defined questions asking, is this concise? And the answer could be yes or no. So the advantage is, if you're doing this for evaluation, you can say it is very clear, aligns with rubrics, and then it is better for systematic evaluation across large data sets. So this is the other part. The part where we should not be using LLM as a judge is trying to get some mathematical answers or some sort of a number that gives you a criteria for whether an answer is good on a scale of 1 to 10 or others. LLMs are notoriously not all that great when it comes to the mathematics part of it, though they have started even answering international mathematics Olympiad questions, but on a generic manner, they really are not good at the mathematics part of it. So it is recommended at this point at least to only do scoring which is not qualitative but which is not quantitative but qualitative. So this is the part here. So now let's look at an example code where we are going to be showing the LLM as a judge, the grading demo here. Okay. We will be sharing this particular Jupyter notebook as well. So effectively, the idea here is we want to use an LLM to grade short answer responses with a simple rubric. We want to know whether the answer is complete, yes or no, accuracy, whether it is good, yes or no, and clarity, yes or no. So it uses binary labels and it also is asking for a rationale for that as well. So let us move on to see the example of the data set here. So as an example, I have a question that says, explain the role of working memory in problem solving. The reference here is talking about a reference answer, and it says the working memory will temporarily store and manipulate information, allowing reasoning and decision making. And the student section here is indicating what the student had answered. Let's say the working memory helps in keeping information active so we can reason through steps and make decisions. So this is one example of one record. There is another record for defined photosynthesis, and then there is another record for what is Newton's first law of motion. Now you can easily think of this as a set of questions that are loaded from a CSV, and that which the student is going to give a lot of answers to based on a given question or a given question paper as such. Now, we have just simply loaded this inside a data frame so that we can go ahead and see that. And now the prompt to the LLM is, you are a grading assistant and you are required to evaluate short answer responses using a binary rubric, return a strict JSON with completeness, accuracy, clarity, and a rational, and then it explains what all of these things mean. So this is the prompt that is being sent to the LLM. In this particular case, we have just used OpenAI directly, and we are now at this point of time iterating through all of our data sets, and we are calling the OpenAI as a LLM as a judge. And so you see here as an example, for student 1, it is giving out a response saying it is both complete, accurate, and it is very clear as well. And it is giving out a rationale saying why it believes so. Now this is simply because the reference answer has also been given there. Now for student 2, if you look at what the response is, let us just see so that we have an anchor point. The question is define photosynthesis, and the student has responded, plants use sunlight to make food. And therefore, under that particular context, it says it's not complete, it's not accurate, and it is clear, at least from a clarity standpoint, and it gives a rationale as to why this particular rating has been given as it. Excuse me. So this is an example of how we can use LLM as a judge in the academic grading demo. So now let us tie this together to this particular notion of AI RMS, so to speak, risk management frameworks. That is to say, how can we use this particular concept to go ahead and use risk management measurements for any AI systems that we have. So let us use the MIST AI RMF as an example. Now, again, just for clarity, I'm going to switch over to this particular section so that we can see how the MIST AI RMF is shown here. So this is the MIST AI risk management framework. And if I were to click on this particular framework, you can see here, this also has a govern, manage, map, and measure. These are the main pivots. Under these pivots, there are multiple controls. The control number 1.1 for map is giving you a description for what it means for this particular requirement. And if you were to click on the informational icon, it gives you a description and a recommended set of actions as well. Now, with this particular context, let us return to the LLM as a judge here. So what you can use the LLM as a judge concept here is the MIST AI RMF is emphasizing measurement across the dimensions that we just saw. So this is just a rewording of it in different language: validity, reliability, safety, fairness, bias, transparency, and accountability. So this LLM as a judge can now serve as an automated evaluator for many of these scoring outputs. So what does that actually mean? So as an example, let us look at bias and fairness evaluation. One simple example prompt could be, does this output contain gender or racial bias? So when you start using an LLM as a judge and you give it a prompt around gender or racial bias detection, then you can take any of the outputs of any system that you are designing, give it to the LLM as a judge with this kind of a prompt, and then use that for two things. One, during the training session, see if the model is actually performing well, and during continuous monitoring session, you can always keep monitoring if the outputs are actually having a problem or not, whether the outputs have a bias or they have some sort of a fairness problem. And you can also, of course, evaluate across a lot of these synthetic test cases. So now you see this particular notion can be expanded to transparency and explainability check, safety and harm detection, and completeness of risk documentation as well. The reason why it works here again is the act of actually making something transparent or explainable is much harder than giving a critique whether it is transparent or explainable. The same thing holds for bias and fairness evaluations as well. And that is the reason why you would go ahead and be able to use it directly here within this particular scope. So in order to then finally operationalize it, what you could do is you could take the RMS subcategories, that is to say, govern, map, manage, and others, and you can put evaluation prompts based on each of the requirements. So is evidence of governance documented clearly? Does the response include appropriate uncertainty disclaimers? And these kind of questions will be used as the LLM as a judge in order to evaluate the AI system that you have based on the framework that you want to choose. And now expanding on this, you can now create a library of these judge prompts, and then each having one focus judge with a binary scoring and some rational. And you can run these evaluations at scale with the human validations loop. The same sample code that we had shown can very easily be updated for any of these categories as well. So this sort of brings us to an end for our entire session on the tools usage. So to recap, we looked at all the different tools. Let me just look at the overview of this here. So we were in a position to look at the fairness and assessment tools here. We looked at AI 360 Fairlearn. These were the fairness assessment tools. We then looked at the robustness evaluation tools, the Foolbox and the robustness gym. And finally, we were also able to look at the transparency and explainability, although this particular set is a bit more holistic than just transparency and explainability. We talked about responsible AI dashboard and the AI verified toolkit. And finally, we used LLM as a judge, as an example to do academic evaluation. And more importantly, once that particular concept has been set very clearly, we were able to see how to operationalize this notion of LLM as a judge within this particular context of AI RMS. So with this, we will bring this particular session to an end. We would like to thank you all for attending, and we will stop here to take any questions or comments. I will stop sharing so that I can take any questions in the chat window. Thank you, everyone. I do have one particular question which is open here on the question and answer. And the question here is, when using LLM as a judge, then wouldn't the second judge LLM also need to be evaluated? So the answer is yes and no. The reason that we discussed there is the act of actually creating something is a bit more of a cognitive load than the act of judgment. So within the current context, when you have one particular LLM giving a response, which is either summarization or which is trying to give a response to the student answers and others, then the second judge is not performing the same task as well. The second judge is merely only performing a simple binary evaluation task on the first question directly. So that is where you can go ahead and use the second judge in order to evaluate the first one, but not necessarily as a replacement for the first one. So that is the rationale behind using LLM as a judge here. The question says anonymous attendee, so I hope the question was answered. If you have any additional questions, do please go ahead and ask. I think we have a question from KK. Any good ways to prevent hallucination in AI? So the long and short of it is, it really depends on the scope and the domain in which you are doing the application. So for example, If you have an application where you are in a position to refer the answers to a knowledge base, then you can try to do what is called a tool-based evaluation of the responses in order to do some validation whether the response has some grounding in a knowledge base that we already have. So that is one good mechanism of trying to understand whether the response has been hallucinated or not. The second way that we have heard, and it might actually be a bit more effective, is to use the different LLMs in order to cross check what response comes in. So you cannot necessarily, very authoritatively prevent hallucination from one particular LLM. But if you have one particular LLM giving a response, you can either have as a guardrail another LLM or another tool set that is validating the answer. And the validation can be a bit more prescriptive. For example, you can have a small language model that is validating the response over one particular small domain, or you can have a tool set that is validating the answer based on, let us say, some given knowledge base, where the evaluation is not through an LLM, but a bit more through some direct tool-based mechanism. For example, if you are going to have an LLM give you a response to the knowledge base, you can always say, give me the source where you got this information from, and validate whether the source is prescriptively available inside your knowledge base or not. If it is prescriptively available, you have reasonable confidence to believe the response is not hallucinated. That is one particular way to go about this. KK, I hope that answered your question. Thank you, folks. I will be here for a minute more to see if anybody else has any other question. If not, do please let us know through your feedback forms how you had this particular how you felt about this particular session, and if you have any specific requirements around AI, whether that is risk management or in the regulatory area, do please feel free to contact us at DeepDive. All right. Thank you, everyone. Thanks again for joining. Bye.